Hello, I'm Jose Lopez, a senior design engineer for Mitsubishi Caterpillar Forklift, and I'm here today with Ken Oberholz. Ken is the Global Director of Manufacturing Technology at Huntington Energy Services. Mr. Oberholz has been active in Lean and Six Sigma operations and implementation since 1994. Welcome, Ken.
Thank you, Jose.
Thank you for being here today.
My pleasure.
What to you is lean manufacturing? What are the differences between lean manufacturing and Six Sigma process control, theory of constraints, JIT?
We talk about lean manufacturing, and really lean is elimination of waste. It's that simple, but yet it's that complex. It's a series of principles and processes, and it's a lot of extemporaneous thinking about what we do. Six Sigma is more of a process control and a science. It is statistical process control, but it derived out of Motorola in trying to achieve zero defects, which we know zero defects are really impossible. So if we can achieve a level of process control to Six Sigma, or 3.4 potential failures in a million opportunities, what we really do is narrow down to near zero defect capability in manufacturing.
What technical lean advancements have you seen over your 18 years of experience?
Well, the use of the internet has really helped quite a bit within lean. I've got to say this because lean, again, it doesn't have a set of theories and principles like engineering does. Lean is still the principles and the concepts, but you know, the internet has provided people the opportunity to really show off what they are doing, and chat rooms and groups that are derived specifically from Lean Enterprise Institute have really helped to foster an interculture of understanding of what lean is across a multitude of business practices that are out there.
From your perspective, what important skills should engineers have?
I have two young engineers now, industrial engineers, that I've just brought onto my company. With these two particular individuals from two different schools here within the southern region, they have all of the mathematical skills, the engineering skills that are required, but what they didn't do is they didn't have the process background within manufacturing. And I think, if anything, that's one thing within the engineering field, where students have the opportunity with the work studies, internships with other companies, is to get as much variety and breadth of experience that they can in understanding processes. It gives, I think, a foot up and able to understand in any industry to be able to walk into it and have that inquisitive mind, that inquisitive eye of not just doing the math, but also seeing what is taking place before them.
Do you see any challenges for future engineers?
The biggest challenge, I think, for them to be successful is going to be how can they better themselves to understand as many different industries are out there. Resources are limited. How can you maximize those resources? So understanding a multitude of businesses and processes, that's really going to be the challenge for them, is how can they get into those areas. As you're developing lean and you're developing this culture within your plant, within your factory, it transcends over to the community as well. It's a culture of teamwork, participation, again, just working together, exchanging of ideas. It's a competitiveness not between people, but within people, collectively, to do something better. And that actually helps the community quite a bit as well, as not only the company that they're working for.
What has been one of your most successful implementations of lean practices?
Well, I like to say all of them have been very successful. And I think a company that I got involved with back in the early 2000s, their lead times were growing 18 and 20 weeks to get product to the customer. They had purchased 50% additional machine tools for capacity, and yet productivity only went up 10%. They were upside down. So I got involved with the company, and basically we turned them around. They went from a $5 million a year company to $42 million. Now, not in 1 year. It took several years to get there. But more importantly, within the first 8 weeks, we had cut those lead times down from 18 weeks to 9 weeks. Within the first 3 months, we brought the lead times down to 4.5 to 5 weeks. This becomes a success story, and I think one of the ones I'm most proud of, because we're also able to change the pay structure in the company so that those individuals were earning in 45 hours what they used to make in 60 hours. But their productivity went from 900 units a month to over 1,000 units a week, working 45 hours a work week. So that, I think, is a great example and probably one that epitomizes the aspects of the culture, the aspects of lean, and what it can do for an organization.
Where do you see the future trends and of manufacturing in general worldwide?
When we look to the future, and we're doing the same thing in my own company now, we're taking what we've been doing for 30 years, but applying the new technology, the new machine tools, the new techniques to, again, keep us profitable, keep us productive in the emerging markets that are there. We're going to have to, in some respects, do a major undertaking in investment in capital, but it's very, very quick to get a return on that capital through the increased productivity and reduced cost in employing lean techniques.
Thank you for sitting with us today.
My pleasure. It's been great to be here.